Not a single day goes by without mention of the environmental and climate challenges facing our world. The ice caps are melting and oceans are rising as we quest for answers and durable solutions. The good news is that there are sustainable answers and solutions. One of the most convincing is wind power.
In this program, we will see how wind power can contribute to our common challenge to combat climate changes by reducing the world's CO2 emissions without compromising our energy's security of supply. Denmark has led the way with large-scale wind power. We will see how this achievement has been accomplished and how Denmark plans to proceed even further on a larger scale, exploiting the enormous power of nature to create CO2-free electricity to consumers wherever they are and whenever they need it. Wind is one of the most abundant natural energy sources in the world. And it's cheap, but it's tricky because it fluctuates. The main challenge with wind energy is to ensure a constant and reliable source of energy supply to consumers. And how do we do that when the energy source fluctuates as wind conditions change? This is the amazing story of how to integrate large amounts of wind energy into the power system.
The EU has set a target that by 2020, renewable energy must make up 20% of the total energy consumption. Around the globe, countries aim to reach similar targets. And the potential for wind power is huge. The wind power share of electricity consumption varies a lot from country to country. With a 20% share, Denmark is the leading wind power nation of the world. Let's go to the Danish national grid, to the transmission system operator, to see how they handle 20% wind power in the electrical power system.
In 1980, all the electricity in Denmark was generated by 16 power stations. At that time, adjusting the electricity generation to suit the electricity consumption was, by and large, a question of throwing more or less fuel into the boilers at the power stations as and when it was needed. Today, the situation is different. The power stations still generate a substantial proportion of the energy. However, a fertile undergrowth of energy producers has emerged. Small local cogeneration plants, solar heating systems, and last but not least, approximately 5,500 wind turbines. The task of integrating all the electricity generated by the numerous producers is managed here at the national grid, the transmission system operator in Denmark.
Connecting a few wind turbines to a country's power grid is not a problem. The large challenge is when thousands of wind turbines are connected to the power grid and wind power becomes a large part of consumption. For what do we do with the power when the wind is so strong that we generate more power than we can consume? And where will the power come from when there is no wind? Even with the high wind power production averaging 20% of Denmark's consumption, a high amount of power production is still needed from other forms of power generation. Denmark has some of the most efficient power plants in the world, using both fossil fuel and CO2-neutral biomass. Normally, power plants are not built to a flexible production resulting from fluctuating wind power. But Danish power plants have a high capacity to regulate production. Which main ingredients is Denmark using in order to make wind integration into the power system a success? A wind power share of approximately 20% in Denmark has been reached by employing a number of tools. Naturally, it takes a great number of wind turbines. In Denmark, an effective scheme subsidizes the generation of electricity from wind turbines. Furthermore, they can be connected to the grid for free. Legislation and planning ensure that wind power is first in line to the grid, and a national plan establishes where wind turbines can be erected. A strong and well-developed electricity grid within Denmark and to the neighboring countries transmits energy from the wind turbines out to where consumers are. Denmark is part of a strong electricity market where electricity can be bought and sold. All in all, to accommodate supply and demand and to ensure competitive and fair prices for electricity. A national transmission system operator ensures that the actual generation of electricity and its actual consumption always balance by asking the power stations to step on the brakes or to step on the accelerator, or through import and export to neighbouring countries. Down at the Danish National Grid Control Centre, it's been a hive of activity for some hours. A storm has just passed. In the run-up to a storm, Denmark produces a large amount of wind power. Power stations are, however, still kept in operation, for should the wind speed increase to 25 meters per second, then, for security reasons, wind turbines must be shut down. And when the storm abates, the power stations can once again get ready to take over. All this is taken care of here at the control center.
Here we have an animation of what happened to wind power generation in Western Denmark during the storm. Now, in the hours before the storm, you can see that the wind production was running at a maximum, indicated by the color yellow, and the surplus energy was immediately exported. Now we're nearing the moment when the storm hits the coast, the winds increase dramatically, and one by one, the wind turbines are shut down. There. In these vital minutes and seconds, the people here at the National Grid Control Room are really put to the test. The whole electricity supply for Western Denmark alters in a moment. Wind energy production is close to zero. Electricity export stops abruptly, and Western Denmark goes from electricity provided by wind energy to other forms of power production. Now, when the storm has passed, the wind turbines in Western Denmark can start up again. At the same time that the storm crosses over to Eastern Denmark, the situation here now repeats itself over there. Right now, the people in the control room can catch their breaths. Wind power has been exploited perfectly, producing CO2-free electricity, and the users haven't even noticed it.
Despite the huge challenges of integrating wind power into the grid, Denmark has no intention of settling at 20% wind power.
20% wind power in Denmark is only a partial target. Here we see plans for the future expansion of wind power in Denmark. A share of up to 50% wind power of the total electricity consumption is the target by the year 2020. And how will this happen? Well, that we can see here. In the future, the erection of wind turbines in Denmark will, to a far greater extent, be offshore. The green columns here represent the expansion capacity of the land-based wind turbines, which will level out. The blue columns represent the wind capacity of the offshore wind turbines, which by the year 2020 will account for approximately 1/3 of the total wind capacity in Denmark.
But how will Denmark manage a 50% wind power share, considering the difficulties of integrating merely a half of that today? Let's go to Copenhagen and get some answers.
One of the keys to Denmark's ambition to go from 20 to 50% wind power is located here. A charger for electric batteries. Thousands of electric cars, together with heat pumps for heating, will draw on a large proportion of the energy generated by the new wind turbines, thus reducing the CO2 emissions in the transport and heating sectors. Furthermore, electric cars do not only come in the size of this one here. Many of the big car manufacturers already have electric car models in more conventional sizes ready to be launched onto the market. In the near future, a smart grid system will make it possible to charge your car either quickly or cheaply. The latter, naturally, when most electricity is available, typically at night or when it is windy.
Let's hear what the Danish Minister for Climate and Energy thinks about wind power.
You know, as a country who has a lot of renewables, and particularly wind energy, of course it's interesting if we can find ways to use also the surplus power being generated when it blows a lot, when the wind is very strong. So if we could sort of store it on batteries and drive on these batteries, then of course it will be extremely interesting, not only for Denmark, but to the whole world.
Besides electrical cars and heat pumps, a variety of new tools are needed in order to reach a 50% wind power share of the electricity consumption. These tools could come into play as Denmark expands its wind power production with new and possible future offshore wind farms geographically spread around the country. One of the most interesting projects Denmark is looking into is Kriegers Flak in the Baltic Sea. Both Denmark, Sweden and Germany plan offshore wind farms in the area, and instead of each country separately carrying wind power ashore from its own offshore wind farms, the farms are connected, so that it's possible not only to carry the power ashore, but also to exchange power among the three countries. It could become the world's first offshore mini supergrid, paving the way for future supergrids in the North Sea and the Mediterranean. In this way, the project is highly internationally focused and supported by the EU.
Well, my electric car has been recharged here in Copenhagen. It's time to move on. For many, the Danish Windcase will seem like a distant dream of the future. But climate changes mean that we must find sustainable solutions for the energy we use. Wind power is one of many possibilities, but more than any other renewable energy, the prospect of wind power reducing the world's CO2 emissions by 10 billion tons by the year 2020 is not a distant dream. As we've seen from the example from Denmark, there are sustainable solutions for integrating wind power into an electricity grid. So, when we talk about energy, the future is green. And in Denmark, the future has already begun.